Hey guys, my name is Sia. I'm a scientific assistant at the University of Marburg in Germany, and today I want to talk to you guys about the Heckscher-Ohlin-Model. One of the things I realized when I looked around a little bit online is that there are a lot of people who talk about this equation, and try to give an account on what these equations in the Heckscher-Ohlin-Model include, but there are very little actual calculations with real values. So this is what we are going to do today, have an actual calculation on the Heckscher-Ohlin-Model. But before, let's have a quick recap on what the Heckscher-Ohlin model actually states. So, in an economy with two goods, you have two factors of production, which are labor and capital, and you have to distribute these two factors of production in such a way between the different sectors of the economy that you're able to produce both goods at an optimal rate with the resources available, capital and labor. So, let's dive in, no time to waste. So frequently in the exam, you get questions such as, home can produce two goods, A and B, we say cloth and food. The production possibilities are determined by the following parameters. So let's come up with some figures. We say the total amount of capital available is 2,000, the total amount of labor is 800, the amount of capital in cloth equals 2, amount of capital in food equals 4, amount of labor in capital equals 1, amount of labor in food equals 1 as well. So let's now start and do the actual calculation. So you must memorize two of the following equations, which are quite straightforward, and I will show you a technique which is going to make it even easier for you guys. So now we start with a capital constraint. You can start either capital or labor, and then you have to choose which of these products you want to measure, cloth or food. So we come with capital equals the amount of capital in cloth times the quantity of cloth plus the amount of capital in food times the quantity of food. So now we have to reformulate this equation in order to be able to just plug in our values and just calculate it right down. So we now want to measure the quantity of food, and we have the capital constraint, so we have here capital over the amount of capital in food minus the amount of capital in cloth over the amount of capital in food times the quantity of cloth. Now this seems a little bit confusing, but just see, it's actually pretty easy. You always have that product in the denominator that you're looking for, that you're measuring. So if you're measuring food, make sure you always have food in the denominator, and then you have capital anyway everywhere. And then memorize that you have to definitely put in the quantity of cloth or the second product at the end of your equation. So now this enables you to just plug in these values. So we go for QF equals total amount of capital is 2,000 over amount of capital in food, it's 4 minus amount of capital in cloth over the amount of capital in food, which is 2 over 4 times the quantity in cloth. This then is 500, 2,000 divided by 4 minus 2/4 is actually a half. QC. This is it. This is already our constraint with regard to capital in terms of the quantity of food. And now let's do the constraint with regards to labor. So now let's calculate the labor constraint. We have labor equals the amount of labor in cloth times the quantity of cloth plus the amount of labor in food times the quantity of food. Now again, we have to reformulate this equation. It'll become quantity of food equals labor over the amount of labor in food minus the amount of labor in cloth over the amount of labor in food times the quantity of food. So now, again, just plug in these values and remember to memorize this equation. So now we have QF equals 800 over 1 minus 1 over 1 QC. Then you have QF equals 800 minus 1 QC. And this is already your labor constraint. So now let's go ahead and graph the production possibility frontier. This is one of the other questions that you will frequently encounter in the exams. So let's go ahead and draw our production possibility frontier. And we do already have our results with regards to the constraints in the quantity of food. So on the y-axis, we just write quantity of food. And on the x-axis, we are looking for the values in terms of the quantity of cloth. So now you just insert 800 and 500. You have 800 and 500. And we are looking now for the values on the x-axis. So how do we come up with those? It's actually quite straightforward. So you just divide the 800 by the slope of the isoline. And the slope of the isoline is always the quantity of food in terms of our constraints. So 800 divided by 800 remains 800. And 500 divided by a half gets 1000. Now you just need to simply connect these lines. 800 to 800, 500 to 1000. So where is now our constraint? Our production constraint is always the interior of both isolines. So now we have a tilted curve, and you always should indicate this in the exam by using a color. So this tilted curve is now our production possibility frontier. So guys, this is it. And if you have any further questions, don't hesitate, write it below into the comment section, and I'm more than welcome and happy to answer your requests. Have a good one.